Section 5, question 13. The amount A micrograms of a certain radioactive substance remaining after 2 years decreases. According to the formula, AT equals A naught e to the minus 0.02t, where A naught is an amount initially present. Part A says, if 600 micrograms are left after 1000 years, how many micrograms were present initially? The best way to think about these decay questions is to think about them either as a section 1 or a section 2 question. Section 1 type question is one when you're looking for an unknown power. Now, in that type of question, if you're looking for an unknown power, that just means you're looking for something that's unknown up in the power line. That means you need to take natural logs of both sides. The kind of second type of question with these ones is just a straight substitution. So if I look at part A says that 600 micrograms were left after 1000 years. How many micrograms are present initially? That means that I need to find out what A naught is. Now that's not an unknown power. An unknown power would be to find what T is up in the power line, but A naught is not up in the power line. So I would say that's a type 2 equation, which is just to make a substitution. So the time we can see is given by 1000 years. Now, A naught is what I'm looking for, and AT is the amount after 1000 years, and that's 600. So I'm going to now change the subject of the formula to A naught. So AT equals A naught e to the minus 0.002t. So that means that A naught would be equal to, so I just bring that down. So A naught would be AT divided by e to the minus 0.002. So AT is equal to 600, and it's 600 divided by e to the minus 0.002. And I'll just enter that into the calculator. So a slight mistake here, it's e to the minus 0.002 t. So t is 1000 years. So it will actually be A naught equals 600 over e to the minus 2. And that will give me 4,433 micrograms. That's part A. Part B says the half-life of a substance is the time taken for the amount to decrease to half its initial amount. What's the half-life of the substance? Well, half-life is a measure of time. Now we can see that the time is up in the power line. Now that's an unknown power. That means that eventually we're going to have to take natural logs of both sides with this type of question. So a kind of good way of thinking about this is the half-life. What do we know? We know that the initial amount decreases after a given amount of time to half of the initial amount. So the amount at any given time can now be given by half A naught after the half-life time. So half A naught equals A naught e to the minus 0.002t. So what we can do next is cancel the A naughts, and we'll get e to the minus 0.002t is equal to 0.5. Now only when this bit is flush, we're just starting e with nothing in front of it. Only when we get to a point where there's no value in front of it and we're ready to take natural logs. So we are. So the next thing that I would do is communicate that to the examiner. So we're going to take natural logs of both sides. So that's log to the base e of e to the minus 0.002t is equal to log to the base e of 0.5. We're then going to use law 3, which is to bring that power down, and that will be minus 0.002t log to the base e of e is equal to log to the base e of 0.5. Now, we know that it's a law that log to the base a of a, log to the base 5 of 5, log to the base 2 of 2, log to the base e of e is equal to 1. So that will collapse down to minus 0.002t equals log to the base e of 0.5. T is then equal to log to the base e of 0.5 divided by minus 0.002. Now in the calculator, log to the base e is given by the ln button, so it's ln 0.5 equals divided by minus 0.002, and that will give me 346.6 years, and that is the answer for the half-life.